Hi, this is Sayed Amir Alavi. In this experiment, we are going to build a DC-DC buck converter with Arduino Uno. You should have already received a pack of the components. In this video, I'm going to introduce the components, but let's first unpack the kit and take a look at them. Now I want to introduce the components to you. After you unpack the kit, you have a battery contact, a battery, the breadboard, the USB cable for programming the Arduino Uno, there are the jumper wires which you need to connect the components together on the breadboard. This is the 100 ohm load resistor. It's a 5 watt high power. These two are 1 kilo ohm resistors. This is the inductor and these are the capacitors. The capacitors have 100 microfarad capacitance and the inductor has 100 microhenries inductance. This is the P-channel MOSFET that you are going to use as a switching component. This is the NPN by BJT bipolar junction transistor, which acts as a gate driver. This is the diode. This is the potentiometer, which acts as a variable resistor to adjust the PWM duty cycle. And this is the oscilloscope and the power supply for the oscilloscope with the probe that you need to view the waveforms on different parts of the circuit. In this section, we are going to prototype the DC-DC converter circuit. I have already connected the components on the breadboard and the Arduino. The Arduino is already programmed with the PWM generator code. These are the load capacitor and the load resistor. You have also the inductor and the capacitors, which you will use for other experiments. So if we want to use the oscilloscope, we prefer to put it in DC mode. It will allow us to measure both the DC component and also the AC component of the waveform. Now we are trying to connect the oscilloscope probe to the output connectors, which is the negative output and the positive output. This is the negative part and this is the positive part. Now you can see that the voltage is stable and it is 0 because the circuit is not powered on yet. You can see the average value of voltage there as well. So we need to connect a battery. The negative side is the black wire and the positive part is the red wire. You should be careful that these two wires don't contact each other. Otherwise, the battery will be short circuit and it will lose its energy. So one way is to detach the battery contact to make sure this doesn't happen, or if you want to keep the battery attached to the battery contact, make sure the wires are far from each other that there is no chance that they will contact each other. Now we are powering on the circuit. First the negative connection, and second the positive connection. You can see that the Arduino is powered from the battery, and the output voltage is still 0 because the potentiometer is turned to the maximum value, which gives us 0 duty cycle. After you try to move the potentiometer, you can see that the output voltage changes. Also, you can see there is a small ripple on the output voltage. You can see the average voltage on the oscilloscope as well. So by changing the position of the potentiometer, you can change the duty cycle of the DC-DC switching. Also, you can see that the voltage changes when we move the knob. The voltage should change from 0 to the maximum voltage, which is the voltage of the battery. Now we want to measure the PWM signal that is generated by the Arduino. You can see the PWM signal on the oscilloscope. Now if we move the knob or the potentiometer, you can see that the duty cycle changes. If you want to see the waveform better, you can change the time division. And again, you can see that the duty cycle changes by changing the position of the potentiometer. Now we want to take a look at the output voltage ripple and see how we can measure it directly. In order to measure the ripple, we should change the mode of the oscilloscope to the AC mode. This way, we can see only the AC part of the signal, which is the changing or variable component. As the voltage is in its maximum, the ripple is low. You can also increase the voltage division to see the waveform better. As we decrease the voltage, you can see the ripple is increasing. This is due to the charging time that is needed to charge the capacitor, and you can see that the ripple increases by lowering the voltage. This can, however, be compensated by adding extra capacitors in the output. Also, the flywheel circuit with the inductor and the diode can help reducing the effect of the ripple, and we have a clear, smooth voltage on the output. You can do more experiments with the other components we have been given, like the inductor and the other capacitors and the diode. Thanks for watching this video.